Thanks, Moki, for the kind introduction. Augmented reality promises to enhance the real world around us, improving the way we play, learn, and work. Today, most people on this planet have a device that can do AR, their mobile phone. Our mobile app, Snapchat, is built to bring people together with their friends and family. You've probably heard the phrase that a picture is worth 1,000 words. That's why Snapchat opens to the camera, inviting people to communicate visually. The Snapchat camera opens to augmented reality experiences, which we call lenses. 850 million people use Snapchat, and over 300 million Snapchatters engage with augmented reality every day on average. Snap has enabled people to use AR on their phones for almost 10 years. But with a phone, you still need to hold a screen in your hand, and you have to look at that screen rather than the real world. Snap recognized this long ago, and for about 10 years, we've also been working on AR glasses, which we call spectacles. The first 3 generations of spectacles were capture glasses that allowed users to take pictures and videos and share them with their friends. The 4th generation, in 2021, was able to run lenses directly on the glasses, same as the Snapchat app does on the phone, but in stereo and full 3D. Last month, we launched our new 5th generation spectacles and our purpose-built brand new operating system called Snap OS. These spectacles are lightweight and wearable, totally standalone, no puck, no cable, no tether, and no phone required. They allow you to see and stay grounded in the real world, so you can share experiences together with friends and family. We launched these AR glasses at our Snap Partnership Summit. Hundreds of attendees got to try spectacles that same day. And we also shipped our first pairs of spectacles to developers at our LensFest event the next day. No other AR glasses available today have similar capabilities, and they are a huge step forward from our previous generation. Spectacles are a real product that are available to AR developers right now. Our Spectacles developer program also includes support from the Snap team to help bring your imagination to life. Today, I'm excited to give you a closer look at Spectacle software and hardware and share how we are working towards being the most developer-friendly platform in the world. Within the first few weeks after the Spectacles launch, we've seen a ton of positive reactions from our Spectacles developer community. Our CEO, Evan Spiegel, was so excited that he shared this message.
Hey everybody, it's been just a few short weeks since we launched the 5th generation of Spectacles powered by Snap OS. And already there are amazing developers and lens creators building such cool experiences for Spectacles. So here's a couple of our favorites, and we can't wait to see what else you create.
I'm very happy to make a special announcement today. We launched our new Spectacles 6 weeks ago, and so far they're only available in the US. But we are working on rolling them out to more countries. Within a few weeks, we will start to make them available in multiple European countries. That is, in France, in the Netherlands, in Spain, in Germany, and Italy, and in Austria. Spectacles use optical see-through lenses called waveguides, so you stay grounded in the real world. Our waveguides use billions of nanostructures that reflect the light from the miniature projectors built into the temples of Spectacles. This optical engine has been designed and built from the ground up right at Snap, leveraging our proprietary technology. With optical see-through, users perceive the real world with proper focus distance, rather than as a pair of flat stereo images. There are also no limits in dynamic range and resolution for the real world. And the real world has true zero latency, which helps to avoid motion sickness. Our 46-degree field-of-view displays have a super sharp 37 pixels per degree. The displays have a focus distance of 1 meter, which is great for near-field content. And they run at 120 Hz for low latency. These displays are super bright, and they have a switchable dimmer, which probably makes them the only AR glasses that are also suitable for outdoor use. Spectacles provide more immersive experiences using less power thanks to 2 Snapdragon processors from Qualcomm, one on each side for maximum compute power and thermal dissipation. With a titanium vapor chamber for improved heat dissipation, spectacles deliver 45 minutes of continuous runtime. And if you're like me, you'll be happy that there's also an option for prescription lens inserts. For our new spectacles, we also developed a new operating system called Snap OS. Snap OS has a unique user interface that is optimized for hand usage. Here in this video, you see Lens Explorer, which allows you to browse the currently installed lenses. At any point in time, you can pause a lens and open the system menu by tapping the button on the left of your hand. There, you can change brightness, volume, and more. Multi-user experiences are supported at OS level. If a multi-user lens is running nearby, then Lens Explorer shows that. And you can join directly with a single button click. All you then need to do is look around a little bit to localize against the already running experience. And you're in. It's that simple and no need for markers. Let's briefly look at some of the system-provided gestures. The first one here we call direct pinch. You reach the button and pinch it with 2 fingers. You can also move objects around by pinching and dragging them. And you can use 2 hands to resize and rotate objects. If objects are further away, then you can use targeting, which shows a 3D cursor to select objects. For this, you don't need to hold up your hands. You can do it with your hands all the way down, like here. And of course, buttons can also be pinched at distance. The new Spectacles mobile phone app is a great companion to help manage your glasses. When you pair Spectacles with your phone, it guides you through the setup process, including measuring your eye distance, which is important for accurate 3D rendering. The app imports videos captured on Spectacles, and it allows you to bring content from your phone to Spectacles, so you can browse it in AR. It also allows device settings to be adjusted, and it keeps your device up to date with over-the-air updates. The Spectacles app can also become part of your AR experience. For example, you can use spectator mode to watch the same lens as the glasses user, but on the phone and from a different position. With phone mirroring, you can use your favorite phone apps in AR by streaming your mobile phone screen to your glasses. And with the controller feature, you can use your mobile phone as a 6 degrees of freedom input device. In the video here, you see a golf lens that uses the phone to give you the feeling of having a real golf club right in your hands. Developing lenses for Spectacles is made easy using Lens Studio, which is known as being the best development environment for augmented reality. Everything is fully integrated. You don't have to piece together separate tools to build a lens. Within Lens Studio, you can directly build, optimize, and distribute your lenses. Lens Studio focuses on fast iteration. You code in TypeScript, and immediately see the results in the preview window directly in Lens Studio. And when you're ready to test on device, you can push your lens to the device either wirelessly or via USB. When you're ready to profile, open up the Spectacles monitor to see thermal, power, and CPU data. And finally, when you're ready to publish your lens, you can do that right in Lens Studio too. But Lens Studio isn't just a developer tool. It is also a community repository of building blocks for lenses, made possible by our asset library, which is full of contributions both from Snap and the wider development community. These assets range from 2D assets and 3D models all the way to pluggable machine learning models, reusable scripts, and licensed music. Lens Studio is also where Snap regularly deploys packages of new functionality. And the most important package for Spectacles developers is the Spectacles Interaction Kit. Spectacles Interaction Kit provides all the building blocks to easily create interactive AR experiences and dramatically streamlines lens development for AR glasses. All the UI elements support both hand tracking as well as using the mobile controller, which we saw before in the Golf lens. Spectacles Interaction Kit is provided with full source code. Per default, it is set to read only, but if you want, you can go in and make any changes you like. It is easily extensible, and it is designed to be modified. Here are a few examples of how you can use Spectacles Interaction Kit, which helps you, for example, placing new objects meaningfully, and they can also automatically follow you. This makes it easy, for example, to prototype LLM-based applications. Here, you see how UI elements can react to each other as well as to the environment. Spectacles Interaction Kit also makes it easy to grab objects and move them around. In this example, the way how the blocks align to each other is custom, but how they react to the user grabbing them uses default mechanisms. Another highlight of SnapOS is connected lenses, making it easy to create shared experiences. The feedback we gathered over the past 6 weeks since we launched Spectacles is very clear in that people love shared AR experiences. Due to their optical see-through displays, Spectacles users stay grounded in the real world and together with their friends and families. In a connected lens, all participants use the same shared coordinate system, and the lens state is synchronized between all participants, so that they interact with the same AR content in the same place at the same time. We've made it easy for developers to build their own connected lenses. Everything you need is already available directly in Lens Studio. Our sync framework is a collection of scripts, components, and UI elements that manage the session and sync the data among the users. Developers can build and test connected lenses right in Lens Studio by simulating multiple users with multiple preview panels. Each preview panel simulates an individual user. Augmented reality is by definition interactive. It is therefore important that Spectacles can sense what is happening around them. Let's look at some of the Spectacles computer vision features that you can use in your lenses. And let's start with hand tracking. Hand tracking is our main input modality, which means users will use it almost all the time, in the system UI as well as in your lenses. We therefore worked hard on making this hand tracker work well in many different scenarios, indoors and outdoors. Since much of our UI requires overlapping hands, we ensured this works really well. The hand tracker gives updates to lenses at a rate of 60 Hz. Via the hand tracking API, you can get the 3D coordinates of all 21 landmarks of each hand. Earlier, we looked at the system-provided gestures, but with the hand tracking data provided to lenses, you can, of course, also implement your own gestures. Additionally to the two main color cameras, spectacles also have two infrared cameras, which point downwards. We use these infrared cameras to track the hands even when they're below of what the color cameras can see, as this video shows. With this, hand tracking works all the way down to your waist, like this. We call this the T-Rex pose. And in many cases, it is much more comfortable than holding your hands up like this, as many other glasses require you to do. Let's look at some of the spectacle's scene understanding capabilities. Scene understanding is important so that lenses can react to and interact with the user's environment. Depth maps, as shown in this video, are the foundation for various other algorithms, such as real-time collision with dynamic objects. Or if you have an object detector, you can sample the depth of the detected object. This depth map estimation is based on machine learning. So like all spectacles features, it works well indoors and outdoors. SnapOS has built-in functions to get the distance and surface normal for any object in your close vicinity. With this, you can enable users to interact with the real world by, for example, casting rays from their hands, as this video shows. What also works well is to combine this feature with gaze and dwell, to let users place content on real surfaces just by looking there. We found this makes it really easy for users to select the location of the main scene, somewhere on the floor, without any hand interactions, or on a table. Another handy feature of SnapOS is building a rough surface model of the planar, horizontal, and vertical surfaces that surround the user. This can be helpful for automatic placement of virtual content. For example, for a game on spectacles, this mechanism can be very valuable to place game content meaningfully in the environment. And if you need more details than points and dominant planes, you can ask SnapOS to construct a triangle mesh of the static environment. This can be useful to get the object boundaries or the extents of the physical space. And it works well for physics-based interactions with the environment. Lens Studio comes with many features that we added to enable creating great AR experiences. However, if the built-in features are not sufficient for your needs, then you can use SnapML to build your own. SnapML has been hugely successful with Snapchat on the phone, so we also brought it to spectacles. SnapML enables lens developers to deploy their own machine learning models for their lens. You can import models created by many different frameworks, such as PyTorch, TensorFlow, and others. SnapML automatically optimizes your ML models for the specific platform it runs on, and it can work on live camera input. Let's look at a few lenses that use SnapML and how they do it. Take, for example, this basketball lens that uses SnapML to localize the ball, to get the 3D location of the hoop, and to detect whether the ball is inside the hoop. This would not be possible with the features provided by Lens Studio directly, but with SnapML, you can create your own models that do these things. Let's look at the scoring function that estimates when the ball is going through the hoop. First, we trained a model with positive and negative cases of a ball inside the hoop. This training data is a mix of real images and images rendered using Lens Studio. On spectacles, the model runs on the live camera image. For this, in Lens Studio, you set up a color image as input and a one-by-one output, which reports the scoring value. At runtime, after model inference, the lens just checks if the result is larger than some threshold. Tracking the basketball hoop in 3D works similarly. We trained a detector that runs on the camera image and outputs 8 heat maps for the 8 separate locations on the hoop. Each heat map gives the likelihood of where the respective part of the hoop is in the current camera image. Then, For each heat map, we calculate a center point. So we end up with 8 2D pixel coordinates in the current camera image. Finally, we use a function from Lens Studio called solve_PNP that calculates the 6 degrees of freedom pose of the hoop. We just saw that SnapML can be great for making your own computer vision algorithms that can run very efficiently due to hardware-accelerated machine learning inference. But SnapML can also be used for audio processing. This piano tutor lens uses SnapML for audio pitch detection to check if the user is playing the song correctly. Let's briefly look at how this works. The lens uses the Spectacle's microphones to capture the sound emitted by the piano. This is a simple waveform audio signal. The lens passes this signal to a Lens Studio function called MEL spectrogram, which executes a fast Fourier transform to convert it to a frequency domain signal. And finally, the lens runs an ML model to detect certain music notes in that frequency signal. The most compelling AR experiences are probably those that understand the world through the camera on your device and respond to what you see. Imagine being able to run your own LLMs in the cloud or your own cloud-based computer vision models against your real-time camera stream. But camera data is sensitive and private. Because of this, today, when you access camera frames, we disallow your lens from also connecting to the open web. But this is only temporary. We have solutions underway to open up internet access while securely and privately giving you also access to the camera. For example, soon we'll bring the power of cloud-hosted multimodal AI models to spectacles through a new partnership with OpenAI. This will help developers bring new models to their spectacle experiences to provide more context about what you see, say, or hear. While we build these solutions, you can still already test out your ideas now via extended permissions. When extended permissions are enabled, you are able to access both camera and the open internet. The only caveat, you cannot publish a lens that has extended permissions. Okay, we looked at many examples of what you can do with spectacles today. Spectacles enable new use cases that were not meaningful or possible before. They have 6DoF tracking, hand tracking, scene understanding, camera access, multi-user capabilities, and you can use your phone as part of the experience. And if all that isn't enough, you can use TypeScript and SnapML to develop completely new augmented reality features. The possibilities are almost endless. If I got you interested and you want to get access, then go ahead and join our developer program. And of course, use the opportunity to try them here at our booth over the next 2 days. If you want to know more about Spectacle's hardware and software and some of the design choices that we made, then watch our talk called The Path to Spectacles on YouTube. We are grateful to all of you for being part of the community that pushes these technologies forward. What will you build with the Snap Era platform? Thank you.